Now we solve gate problems related to control unit. Okay. The first gate question. A microprogram control unit is required to generate a total of 25 control signals. Okay. Assume that during any micro instruction, at most 2 control signals are active. Minimum number of bits required in the control word to generate required control signals will be. So the question is about minimum number of bits required to store in the control word to generate this control signals. But at a time, at most 2 control signals are active. Okay. Now I will tell you one question. If the problem is exactly 1 control signal is active, what we can do, I will tell you. Only 1 control signal. If you don't want to do optimization, answer is directly 25. Because what you do is you take a control word with 25 bits. Okay. So whatever, now whether it is 1 control signal active or anything doesn't matter. If you don't want to save the space, then we can use 25 bits. So this will work for any pattern. Example, let's say 7 control signals are active. They are C1 to C7. Still what I can do is I keep the first 7 bits ones, remaining are zeros. Okay. Example, C1, C7, C9 are active, remaining are passive or I can say inactive. Then we can easily represent it, right, with 25 bits. If you want to say that C1, C7, C9 are active, then C1 bit make 1, C7 1, C9 1. All other bits should be zeros in that way. So with 25 bits we can generate. That is what the regular story. But here I have to optimize. Correct? Minimum number of bits are required is the question. Then, so the minimum number of bits, if you want to answer that, what we can do is we can use a decoder and we use only 5 bits. Okay. Let me use only 5 bits and let me generate exactly 1 control signal out of 25. How I will tell you. Need to remember, if you have a 5x32 decoder, what it can do is, so this is your 5-bit control word. Okay, this is your 5-bit control word. So that control word, if you connect here to your decoder, which is 5x32 binary decoder, this is called 5x32 binary decoder. The property of binary decoder you know, right? So if it is 5x32, there will be 32 output lines. Okay, 32. But we don't want 32 output lines, right? We want only 25. Then what we do is we only select 25. So let us call this as C1, C2, C3, C4 up to C32, right? But I take only up to C25. Remaining I ignore. Okay. Now how this decoder works is, example, if you represent in your control word 00000, then C1 will be active. If it is 00001, then C2 will be active. If it is 00, that means there are 32 patterns. You should understand that, right? There are 32 patterns. Based on each and every pattern, one of the output line will be active, all others are inactive. If you have this kind of decoder and this kind of circuit, how can we use it? We can use it for generating exactly one of the 25 signals, correct? Example, you want to only generate C1 signal. Then simply represent 00000 in the control word, right? Now we solved a sub problem. What is that sub problem is, you have 25 control signals, but out of them exactly 1 is active at a time, exactly 1, right? Then what I can do is I can use 5x32 decoder. Okay, so but because we need 25, right? Sir, why don't you go for 4 by something? The 4 by decoder is, see, the model of decoders are generally 4 into 2 power 4 decoder. You will be having 4 into 2 by 4 decoders. Then with that only 4 by 16, you can have only 16 patterns, right? 16 output patterns, otherwise 16 output lines. Then I can generate at most one of the 16 control signals. That's why I don't want that. That's why I'm going for 5x32 and I'm using 25 lines. Remaining 7 lines I'm not using. Understand? Now you see how I am going to use it. So my question is, you have 25 control signals and exactly 1 control signal you have to generate at any time, at any micro instruction. Okay. Then what I can do, I can use this 5x32 decoder and I use a control word of 5-bit, right? Now example, really I want to activate C4. For that I use a control word like this, 0 0, maybe see I think 0 1 1 I can use anything, like we can plan it, not a problem. Okay, so that is about decoder. This decoder can be used, but that is not our final problem. What is our final problem? We have a requirement where sometimes two control signals also should be activated, right? So for that, what we can do is use this kind of decoders too, and use two sets of control words of 5 bits. You see how I do. So these 5 bits you connect to a decoder, okay, so that this decoder structure will be 5 by, let us say 25, because however the other 7 lines are unnecessary for you, right? Let us use 5 by 25 decoder, and it will create 25 outputs. Okay, each output you can represent as a control signal, right? So now what you do is you plan it such a way that, so whatever the use these binary patterns and map them to one of the output lines. That's it. Example, let's say 0 0 0 0 0 may enable C1, 0 0 0 0 1 may enable C2, 0 0 0 1 0 may enable C2, C3. In that way, so all that C25 signals can be planned. Understand? Now similarly, what I do is I take another word with 5 bits. Okay, again I connect them to another decoder. So what this decoder is going to do is, it is going to have 25 output lines again. So each one I connect to again control signal C1 to C25. Now according to this decoder property, when you give a input of 5 bits, it will only activate one output signal. Okay, that is traditional decoder. So if I use the traditional, that is nothing but a binary decoder. The property of binary decoder is each input pattern, for each input pattern, exactly one output will be activated. Now we can use this kind of output lines for enabling the signals. Now what is our question? We have a requirement that sometimes we have to enable two control signals, sometimes 1, sometimes 0, because at most 2. Now I will tell you. Example, you want to enable C7, C9. C7, C9. What you do is, using this set, okay, this binary pattern, plan a pattern such a way that C7 will be enabled. Plan a pattern, okay, plan a pattern so that C9 will be enabled here. In that way, so using these two, we can generate at most 2 control signals, right? And one more thing, this circuitry, whatever you are taking now, can generate at most 2 control signals, because here you are getting only one control signal active, here only one control signal. So finally, exactly 2 control signals will be active, correct? So that is what we can plan. Understand? So finally, 5 plus 5, 10 bits. Using the 10 bits, definitely we can, do this stuff. So if you see the options, 10 is there. But here remember one thing, actual answer is not 10. If you go for a complicated decoder, there are some complicated decoders. How they work, I will teach you in digital, but I just give the rough idea. If you use that complicated decoders, then probably with 9 bits also we can do it. For that, only understand this stuff. Any decoder when you have, okay, it's all about patterns. How many patterns that input can generate. Example, let's say you have 3 input bits, A1, A2, A3. Then you can realize 8 patterns. Okay, you can plan 8 patterns. You remember at this moment, that's it. Okay, you have 3 inputs, but you want to generate 8 patterns. Then we can use 3 by 8 decoder, not a problem. It's all about number of patterns you have. Now we will come to our problem. How many patterns we have? If you see the patterns, we have 25 control signals, correct? Let me write it, C1, C2, C3, so on, C25, right? But they are not random, right? That means they are not randomly getting enabled. So the patterns, if you see, assume that, let's say, at least one control signal should be active, okay? Generally in any machine, for any work, if you want to do some work in the circuitry, at least one control signal should be active. That's why, that is what, general assumption. Okay, that's not a big deal. Let me assume like that. That doesn't change your answer. So if that is the case, at least one control signal should be active. According to our problem, then we can understand our problem like this. At most two control signals means exactly one control signal. Maybe you have to generate exactly two control signals, correct? So what I am telling is exactly zero control signals is not possible generally, not required. Why? You are not generating any control signal, then you can't do any micro operation, right? So to do any micro operation, at least one signal should be activated, correct? That is what the idea. So let me assume that, let's say exactly one control signal or exactly two control signals. That means at most two control signals. So how many, let us come to mathematics. You have 25 signals, okay, C1 to C25. Before minimizing, how many different binary patterns are possible so that exactly one control signal will be generated? We can do like this. To generate C1 and all others are inactive. This is one pattern. Exactly one control signal active means maybe 1 followed by all 24 zeros or 0 1 followed by all zeros, in that way. So how many patterns are possible? Now I am coming to patterns. So the number of patterns possible is 25, correct? Where exactly one control signal is active. Now how many patterns, binary patterns are possible which represents exactly two control signals are active? Think about it. Simple. There are 25 positions, right? Take two positions and write ones. In everywhere you write zeros. Then how many ways I can do that? 25 C2 ways. Please attend my combinatorics lectures. In that one, I clearly taught that how many binary numbers are possible with exactly two ones, 25 C2. If you simplify it, you get 25 into 24 by 2, which is 300. Okay. Now, how many binary patterns are possible with exactly one? So they are 25 C1, right? So finally, if you see the total number of patterns, 300 plus 25, 325, correct? Now, these 325 patterns should be generated. For that, how many bits are required? Don't use 25 bits, right? Using 25 bits, you can generate 2 to the power of 25 patterns. But all that patterns are not required. Only few patterns are required. How many? So, 325, we can use decoder. So, the decoder requires how many inputs, Example, for 16 different patterns, you require 4 by 16 decoder. If you have 4 outputs, then 2 by 4 decoder is required. So if you want to generate 325 outputs, that means 325 different patterns, okay, then exactly what kind of decoder you require, So it will be definitely log 325. Remember the formula. So log 325 is, approximately 9, right? So 9 bits are required. 9 by 512 decoder we can build, so that this can be used for generating 325 patterns. So that's why answer actually 9, okay, but there is no 9 answer, right? So examiner is thinking about a simpler circuit. See, this 9 by 512 circuit will be little bit complicated one, okay, but that 5 by, if you use 5 by 32 2 decoders, then it will be, they will be simple circuits. But this 9 by 325, whatever the circuit, to realize it, it would be little bit complicated. That's why probably he might think like that, okay. Finally, whatever, in the options we have only one suitable answer, which is 10, right, which is near to 9. Example, let's say you thought about, realizing a complicated circuit. So you realize that 9 bits are required, okay. So this 9 is not there here, so go for 10, that's it. Understand? In any way, final answer is C.